geometrical progressions and arithmetic progressions, APs and GPs, are probably one of the most simplest things that you will learn at maths. So I do not think that there is something worth explaining because everything is straightforward in that formula, where A is the first term, R is the ratio, D is the difference, and N is the term that you want to find. Or sometimes it'll be the final term, sometimes it'll be the term in the middle, and so on. It's not that it's not something that takes a long time to understand compared to other topics at least. But there is one thing that people might not understand. That will be sum to infinity here. This one, sum to infinity, also known as a over 1 minus r. So I'm going to explain why sum of infinity works in two ways. One is theoretically, and one is by calculation. So theoretically, if you were you might normally think if you were to add numbers together, it will never end. Like, the number will be too big. You cannot, if you add numbers infinite times in an AP or a GP, then the number should be infinity, right? You cannot calculate it. For example, 2 plus 4 plus 6 plus 8, or 2 plus 4 plus 8 plus 16. If you were to keep going and going, you will never reach a definite number unless you have a term where you stop at. But there are actually some GPs, APs, they never work. Some GPs, which if you have an infinite progression, they will have a finite value. What I mean is, they will have a specific value no matter how many times you add it. If you make it go to infinity, it will stop at that specific number. So what do I mean by that? For example, these progressions only work if r is between 1 and minus 1. That's because r has to be smaller than 1, positive or negative. So it has to be like 0 point something, for example. This because if you put it as 0 point something, the number will get smaller and smaller and smaller and smaller. Doesn't matter if it's negative, doesn't matter if it's positive. The magnitude itself becomes smaller and smaller and smaller. For example, if you put ratio as 1 over 2 and a as 2, you'll get 2 plus 1 over 2 plus 1 over 4 plus 1 over 8 plus 1 over 16 and so on. So it'll become 2 and then 3 and then 3.5, 3.75, and then so on. I think it's 3.875 and then 3.9 to something. But you get it, basically. It will not end, and that is because it doesn't. It just keeps getting closer, right? But if you realize the numbers are increasing slower and slower and slower. So in the geometrical progression, the curve will be like this, where in the end it will be too insignificant. Well, it'll just look like a straight line if you make it go high enough. So at first it'll look like it's a very big increase, like 2, suddenly 3 plus 1. Then you will think, oh, it'll definitely get above 4. But the thing is, because the ratio is half, you're only adding it by half the number that you're trying to get to. So by half the gap, basically, you're only adding it by half the gap. So like 2, then 3, and then plus 1 you get 4, right? But you're only gonna get half of it. And then when you get 3.5, you're only gonna get half of it and half of it again and half of it again. And soon enough it'll be something like 3.999999 because the other half of 2 will make it become 4. So this whole thing, if you make it go on and on and on, this whole thing will eventually become 2, but only if you go through an infinite progression. If you were to add them theoretically, like normal calculator stuff, it'll become 3.99999999999 and so on. So but since we're talking about infinity here, it means go until the very end. Theoretically, it will reach 4, but it will only reach 4. So that is the theoretical part. Now, the calculation part. How do you get this formula in the first place? Okay, so before that, I would like to actually say that these two formulas are actually the same. The only difference is its negative values have been changed. What I mean is, if I were to put a negative and negative at both sides, you will this will equal to this, but negative and negative still make positive. So this thing, this r what I want r less than one thing, it's not the end of the world if you don't use it right. The only reason why it's like this is to make sure that the numbers are still positive. That's all. The only thing that you do with it is to make the numbers stay positive. But yeah, like the number here and the number here, or the number here. This one doesn't always stay positive, but that's because some GPs will have a negative sum. But yeah, if you were to put a negative value over here in this one, if you let r here be negative, you will still get the right answer. But I do not recommend you to do it because it will involve negative numbers. So now with that out of the way, I would like to mention why we get this formula. If you know how infinity works, you should know the reason why not by then. So the reason why is r infinity equals to 0. But this only applies if r is a fraction. R is less than 1, r is more than -1. It has to be in the fraction form that is not mixed, not improper, not 3/2, not 1/2. It has to be a fraction that is in decimal form with no ones value. It's just 0 point something something something. Why? Now, if you remember correctly, if you were to square a fraction, it will become smaller. Smaller and smaller and so on. So, again, theoretically, if you were to keep going until infinity, the number will be so small, it will have so many zeros behind it, the number at the very back will be considered very insignificant. Insignificant means it doesn't change anything. It's so small, it doesn't change the equation at all. So might as well just use 0. So yeah, theoretically it can reach 0, but in a calculation type of thing, the number will be so small, it will just be considered 0 in calculations. So after you know that, I'm pretty sure you know why you will get this. Because if you use this for example, a 1 minus 0 over 1 minus 0, 1 minus r, I mean, that will be a